Hi everyone, today we're going to learn how to solve quadratic equations. This is probably one of the more important topics this year that you're going to learn. The quadratic formula is something that has to be memorized. It's not going to be given to you on the exam and they use it an awful lot. So I strongly suggest you start to memorize it today. You don't have the notes in front of you, so I would suggest that you pause the video, copy the wording down, and then we'll come back. You'll also need your calculator, so make sure you grab that too. Okay, now that you have everything copied down, as you recall, standard form of a quadratic equation is ax squared plus bx plus c equals 0, which means one side has to equal 0. And it doesn't have to be all pluses, it could be a combination of pluses and minuses or all minuses. How do you solve using the quadratic formula? Well, you use the quadratic formula to solve for your values of x, especially when you can't factor in t-bar. So you rewrite the equation in standard form. You're going to substitute the values into the quadratic formula and solve. And again, we just talked about how important this quadratic formula is for you to memorize. Another hint when knowing to use the quadratic formula is when the directions say, solve the following equation for all values of x, express your answer in simplest radical form, because the quadratic formula has a radical. And it may also say to the nearest hundredth, which means you wouldn't have been able to factor in t-bar because you would have not had a nice answer. Alright, so let's do number 1 together and see how well we do. First things first, as they say, we have to get it in standard form. So in order to get it in standard form, we're going to actually have to get one side equal to 0. Okay, so I'm going to subtract 6x and add 1 to both sides and end up with x squared minus 6x plus 1 equals 0. So I moved both of these guys here to this side here. Okay, so now it's in standard form. The next step says substitute the values into the quadratic formula. Well, the values in the quadratic formula are values of a, b, and c. So we have to actually tell who are our values of a, b, and c. Remember, the a value goes with the squaring, the b goes with the variable that has no squaring, and the c stands alone. So in this case, my a is a 1, my b is a negative 6, and my c is a positive 1. All right, so now that we know the values, we're going to be able to actually substitute it into our quadratic formula. But first things first is we have to write the quadratic formula. And the more you write it, the more you're going to memorize it. So it's x equals a negative of b plus or minus the square root of b squared minus 4 times a times c, the whole thing over 2 times a. Okay, so we're going to show substitution. X equals a negative of, what's b? A negative 6. So you see how I have a negative of a negative? That's very important. Plus or minus the square root of negative 6 squared minus 4 times a is 1 times c is also 1. The whole thing over 2 times a, which is 1. Okay, so now I'm going to come up over here because I'm running out of room. So now I'm going to simplify as much as I possibly can. X equals a negative of a negative 6 is a positive 6, plus or minus the square root of, I don't know. So I'm going to take everything under the radical and I'm going to plug it in my calculator. So parentheses, negative 6, close parentheses, squared, minus 4 times 1, enter. And you should have ended up with 32. All over 2 times 1, which is 2. So really, that's my answer, but now they're telling me I need to put in simplest radical form and then to the nearest hundredth. Okay, let's simplify the radical. So x equals 6 plus or minus, what's the biggest perfect square root that'll go into 32? You're correct, 16 times 2 over 2. So now I have 6 plus or minus, square root of 16 is 4, radical 2 over 2. Take a look at all those leading coefficients. Can they be reduced? Yes, they can by 2. 2 goes into 2 once, into 4 twice, into 6 3. So my final answer in simplest radical form will be 6 plus or minus, whoops, I'm sorry. It's not 6 anymore because we reduced it. It's going to be 3 plus or minus 2 radical 2 over 1, and I don't need the 1 when it's on the denominator. So there is simplest radical form. Now they want it to the nearest hundredth. So now we're going to have to take our answers and we're actually going to have to split them. So we're going to have 3 plus 2 radical 2 and 3 minus 2 radical 2. And again, this is where your calculator is going to come in handy. In the calculator, you're going to put in 3 plus 2 radical 2, enter, and see what you get. And we need that answer to the nearest hundredth. So hopefully you get 5.83. And then we're going to go 3 minus 2 radical 2, enter on the calculator, and end up with 0.17. So my answers to the nearest hundredth for x will be x equals 5.83 and x equals 0.17. So we solved the equation in simplest radical form and also to the nearest hundredth. That truly wasn't that bad. So let's do another one. Number 2. Solve the following equation for all values of x expressed in simplest radical form. Oh, there's that hint that we're going to need to use the quadratic formula. And then express to the nearest thousandth. And there's the other hint, which means I probably couldn't factor in t-bar that even if I wanted to. Alright, so first things first, is it in standard form? Yes, the equation is in standard form. So now I have to assign my values of a, b, and c. A is 1, b is a negative 10, and c is 13. Now I need to state the quadratic formula. X equals a negative of b plus or minus the square root of b squared minus 4 times a times c, the whole thing over 2 times a. Alright, so now we're going to do substitution. X equals a negative of a negative 10. Be careful. Remember, when you're plugging a negative into the b, it's a negative of a negative, plus or minus the square root of negative 10 squared minus 4 times a, which is 1, times c, which is 13, the whole thing over 2 times 1, because a again is 1. Alright, let's neaten this up and see what we end up with. So I've got my calculator in front of me. So I have x equals a negative of a negative 10 is a positive 10, plus or minus the square root of, I don't know. So on my calculator I've got parentheses negative 10 close parentheses squared minus 4 times 1 times 13, enter. Tell me what you got. Hopefully you ended up with 48, just like I did on my calculator. And then on the bottom, 2 times 1 is 2. So now we have to simplify it. X equals 10 plus or minus, what's the biggest perfect square root that'll go into 48? You're correct, 16 times 3 over 2. So let's see here. X equals 10 plus or minus, the square root of 16 is 4, radical 3 over 2. Can it be simplified even more? Let's see. Let's look at all the leading coefficients. Can I simplify even more? Oh yeah, by 2. 2 goes into 2 once, into 4 twice, into 10 5 times. So my answer in simplest radical form will be x equals 5 plus or minus 2 radical 3 over 1, but when the 1's in the denominator, I don't need it. So now the directions say I need to go to the nearest thousand. So now I'm going to need to split it. I'm going to have x equals 5 plus or minus 2 radical 3, and x equals 5. Whoops, and here I just said I had to split it, and we're not splitting it here. It really should be x equals 5 plus 2 radical 3, and then x equals 5 minus 2 radical 3. Okay, let's do this one in the calculator. 5 plus 2 radical 3, enter. Now I need to round my answer to the nearest thousand, so it's going to be 8.464. And let's do the other guy. 5 minus 2 radical 3 in the calculator, enter, and I end up with 1.536 because I need it to the nearest thousand. So my answers to the nearest thousands for x is going to be 8.464 and x equals 1.536. So I solved it in simplest radical form and to the nearest thousand. So those are pretty big problems with a lot of math, but a lot of it was done on the calculator, so really it wasn't too bad. So when you come to class tomorrow, we're going to practice a few more. Have a good evening.